Okay, so again, that's just another way to rewrite it. So if I'm going to do my skeleton step, I'm going to write 5 parenthesis minus 3. Now you're probably, we can jump straight. Where did the 5 and the 3 come from? Question. 5x minus 3. So everywhere where I see an x, I just replace it with a parenthesis. You're probably going to skip this step, and that's fine. But I'm going to show all my work today that I'm plugging in g of x for the letter x. Everywhere where you see an x, you're plugging in g of x. Okay? So again, I'm not a huge stickler about showing every step because sometimes if you show every step, it just would take you forever to do anything. I'm literally writing the entire g function. Okay. So in third period, we stopped there, which that's kind of the main concept that I want us to see is that we're just plugging stuff in. So what would be my first thing I'm going to write down if I'm going to write g of f of x? Great job. I'd start with 2 because I'm looking at the g function. Great job. And I'll put the fx on the inside. Do I need squared? Yes, I do. Good question. I do need the x squared. Okay, I'm literally just writing the entire g function, sorry, the entire f function inside of g. Okay. Now, I've got my 2 out front. I've got my 5x minus 3 squared minus 5. So again, we're going to stop there for right now because eventually we're just going to plug in numbers for it. Now, real quick, if I was going to simplify this, do I distribute the 2 to everything, or do I treat this like I have 2 5x minus 3s? It's going to be a FOIL situation. I would have 5x minus 3 and then another 5x minus 3. This is an incorrect way to distribute that 2, okay? We don't want to do that. We want to treat it as 2 5x minus 3s. Now, why are parts C and D a little different? Great job. 0 replaced x. So you're literally doing everything the same, except you're going one step farther. So under part A, I'm going to write part C. I'm literally doing the exact same thing. What would be my next step to complete part C? What do we think? Great job. We plug in 0 for x. I'm literally going to copy and paste the entire thing. 5 parenthesis. I'm trying to be intentional with the colors, by the way. 2, and then it was 0 squared.
So wait, why is that 5?
Good question, Troy. Give me 1 second to comprehend what you're asking. What's your question?
So why is that of x 5? Why do you put a 5 out there?
Do you see how at the very top it says 5x minus 3?
Yeah.
So I'm copying the 5, and then the x is the function, and then the minus 3 is after the function.
All right.
Like I'm kind of just like substituting in that whole other function. Yeah, Tim. Exactly. Yep. So again, from here we just kind of do PEMDAS. So 0 squared is 0 times 2. Is that still 0? Minus 5. So we have a minus 5 inside the parentheses. Again, there's not a perfect way to show all that work. Okay. So that should be a negative 25 for multiplication. Negative 25 minus 3 should be a negative 28. Okay. Again, this is new for a lot of us, so I'm not expecting us to be great at this yet. I'm just trying to expose you to it today for the first time. Okay. For part B, it's literally the same thing. Okay. Part B and D, yeah. So from here, we're doing part D. Okay. So what's the only difference between the line above part D and what I'm about to write? What am I going to put instead? the x becomes a what? Good job. So there's a temptation whenever you see a 0 to just like say the whole thing is 0, but remember only part of that's going to be 0. So 5 times 0 is 0, minus 3, negative 3. So I have to square negative 3, which turns into what? So it'll be 2 times 9 minus 5. Great job, 18 minus 5, so just a 13. Okay. Again, it's kind of, 1, we don't have enough space to show everything, and 2, I don't need you to show every single step. Okay. How are we doing? Can I get like a thumbs up, thumbs down? Thumbs down means like I have literally no idea what's happening. Okay. Thank you for your honesty. Okay. So for part, the next part, I'm going to do part B and D, and I want you to try part A with your partners. Okay. So for part B, I'm going to rewrite this thing as G. What color is that? F was red. And G was blue. So I'm taking f of x and I'm plugging it into G. So if I'm going to rewrite this, I'm going to write it as G of f of x. Again, my brain is weird. I have to, in my brain, I really need to write it with that red and blue step right there. I get confused with just GOF. Okay, I really prefer it written like that. You'll see both forms moving forward. And this form actually happens a lot in calculus. Like literally Monday, I'm teaching my kids this right here. You don't need to know what I'm talking about. So, again, I'm rewriting it like that. So my function on the outside, should my skeleton step, should that be the blue part or the red part? Great job. The outside, the blue part. So I'm going to write 3 parenthesis squared plus parenthesis plus 4. That's my outside function. I'm plugging the red into G. So again, you're probably going to skip this step, and I'm more than okay with that. But again, we're basically just plugging in f of x everywhere where you see an x. So what's going to go inside those parentheses? 2 minus x. Okay, so make sure I'm not talking while I'm teaching. Now, we're going to stop right there. Thank you. We're going to stop right there for part B. All I did was plug in f for G. So now, do I move on to part C or part D that goes with this? This is part D goes with it, okay, because it has that same GOF. Okay. So what is this telling me to do? When I look at part D, it's saying something inwards. You're replacing x with 3. Great job. So all you're going to do is take that 3, if it lets me. Everywhere where you see an x, you're going to plug in a 3. You kind of work your way from the inside out. So this becomes 3 times 2 minus 3 plus 2 minus 3 plus 4. Again, I realize that this is a lot of like algebra here. So I get negative 1 on the inside right there. Negative 1 squared is 1, so I'm left with just a 3 plus a negative 1 plus 4. Okay. That gives me a positive 7 and a negative 1. That's one way to do it. So it should end up with 6. Now, so I start out with my f of g of x. Again, that was new for a lot of us. If you walk away from class and you only get this, that's what I need, okay? I just need you to be able to understand when you see fog, it means this. When you see goth, it means that. So my f function, my outer function is 2 minus g of x, 2 minus x. So then it becomes 2 minus the entire function, 3x squared plus x plus 4. A common question as I walked around was, does it matter that there's a bunch of x's? And the answer is yes, it does matter. Okay? So now we're ready for part D, or part whatever, C. Thank you. So we've got 2 minus 3 times 3 squared plus another 3 plus 4. Good question. All in the same parenthesis, yes. So what we'll have to do with that red negative? You'll either combine it all and then subtract, or you can distribute it. Good question. Okay, so we've got 3 times 3 squared, which is 27, plus 3,
30, 34.
plus 4, which would be 34.
Negative 34. Negative 32.
Negative 32. Now, classic thing that happens in calculus and any kind of like AP class, does your teacher ever teach you a concept and then they just like give you a question and you're like, I don't know what to do? Okay. That's what's about to happen when you flip the paper over. Now, why is this question different? You have a graph now. You're not actually working with a function like the algebra part. Now you're just plugging it into the graph. I want you to try both of these. That says GOF1. And this says FG2. I want you to change that to FOG, to FOG2. Okay? Change that to FOG2. That was my bad from last year. I forgot to fix it. Okay? So again, try those two with your partner. Again, it's different, but just trust the concept that you learned on the front page. Okay? It's about understanding the language. What does it mean? How can you write GOF1? How could you rewrite that? Great job. I could write it like this first if you want. Sure. But what is replacing the x based off of this first part? A 1. So we're really working with g of f of 1. Change it to 2. Yeah, we're doing the first one first. Good question. So now, again, trust what we know. Do we know what f of 1 is? What is f of 1? I go over 1 and up 5. Great job. So f of 1 is 5. So that should replace all of the blue. This becomes g of positive 5. Again, trust what you know. We already took a test over this, and you guys knocked that part out of the park. We took a test over like plugging in into functions. How do we get 5 from the blue f of 1? So I went over 1 and up 5. Okay, you got it. So now for g of 5, I go over 5, 1, 2, 3, 4, 5, and down to the graph at negative 6. So that answer should be a negative 6. So g of 5 is a negative 6. Who made this up? Somebody that's not alive anymore. Oh, but doesn't it feel good? You learned a little bit of calculus today. Look at that. It's beautiful. It's actually kind of awful. All right, so next one. Should I leave you alone to try the second one?
Yep.
Let me leave you alone to try the second one. Looking at it. Again, we got to be able to translate it. We got to translate it to f of g of 2. So I deal with the inside first. I deal with the red first. Great question. That's what I'm about to talk about. So do we know how to do g of 2? Do I look at the blue or the red graph? Red. G of 2 means you go over 2, down 2. You get the negative 2 right there. Do we understand negative 2? Okay, get negative 2. Then, now, are you going to look for f of negative 2? You're looking at red or blue? Blue. So you start at the origin. You go left 2, up 2, positive 4. So that's why our final answer is 4.